In Think Mathematics, bar models are used to help students solve word problems. Students solve word problems initially by using concrete materials such as cubes. Afterwards, they begin to present their method in drawing the cubes. At some point, they progress from using cubes to using pieces of paper, and afterwards, drawing those diagrams. Bar models are rectangles used to represent numbers and quantities. Bar model is used to help students translate verbal information in word problems into pictorial representation. Bar models is a tool to enhance students' ability to visualize. Bar model also become a bridge between the story and the abstract equation. Bar models are used to help students see which operation is the most suitable one to be used in that word problem, rather than relying on unproductive strategies such as the keyword strategy. Oh, there's a word more in the word problem, let's add, which of course is not necessarily the case. In Think Mathematics, bar model is introduced to students once they begin to solve word problems that require larger quantities. And bar models continue to be used all the way to the upper grades where they need to deal with word problems involving more difficult topics like fractions, ratios, and percentages. And bar models are also used to help students access more complex problems that are not entirely familiar to them. Let's take a look at some examples of bar models in a textbook. For example, on this page, you can see that in the word problem where Min Ho gave 16 marbles to Chris and 9 marbles to Jan, to figure out how many marbles did Min Ho give away, students draw pictures of the unifix cube, giving them the initial ideas to the use of bar model. In bar model, students use diagrams to represent quantities. In this other example, in solving a problem about ribbons, the blue ribbon is 31 centimeters long. The blue ribbon is 12 centimeters longer than the red ribbon. Can we draw models to find the total length of the two ribbons? In this case, using the bar models, students are able to represent the length of the two ribbons and from there figure out how they might be able to solve the problem by selecting the correct operation rather than relying on keyword strategy. Students using keywords might think that since the problem includes the word longer, I might want to add 31 and 12. Incorrectly, of course. However, if the students use bar model, they would have avoided that common error because they can see for themselves in the bar model that the blue ribbon is indeed longer than the red ribbon, and the appropriate operation to use here is not addition but subtraction.